All right, we have our unit circle here. If I were to ask you where sine is equal to -1/2, remember that on the unit circle, the x value is the cosine and the y value is the sine. So basically, we would be looking for where we have a y value of -1/2. Now, you could narrow that down a little bit if you knew that sine was negative in the third and the fourth quadrants, because then you would only be looking at the bottom half of the circle. And you can see that sine is -1/2 right here at 7 pi over 6, and then again right here at 11 pi over 6. But when we work with inverse trig functions, we're going to take that same process and just alter it a little bit. So remember that if something is a function, it has to pass the vertical line test, right? So if you look at the sine curve, it passes the vertical line test. You can draw a vertical line and not hit it in more than one spot. For its inverse to also be a function, it has to pass the horizontal line test. Does the sine curve pass the horizontal line test? No, it would fail, right? Because it's going to hit the graph in more than one spot. And so to have an inverse trig function, we're going to need to only use a portion of the sine curve. So we're only going to use the portion from -pi/2 to +pi/2. If we used that piece right there, notice that it would pass both a horizontal line test and a vertical line test. So it would be a function, and its inverse would be a function. It would be 1-to-1. So anytime that I see arcsine or inverse sine, those are both notations for the inverse sine curve, and it is only going to be valid within the domain of -pi/2 to +pi/2. Now, if you think about the unit circle, +pi/2 goes up here to 90 degrees. Negative angle measures go down, right? So a -pi/2 would go down here to 3pi/2. So you're only looking at the first and the fourth quadrants when you have inverse sine. And what is sine in the first quadrant? It's positive. What is it in the fourth quadrant? It's negative. So if your value is negative, like inverse sine of -1/2, you'll automatically know I only have first and fourth to choose from, and it's positive in the first, so I have to be in the fourth quadrant. All right, so when I see this notation for inverse sine, here's what I know. I know that I am doing the inverse or the opposite. We've been calling it playing Jeopardy. They're giving me the answer and they're looking for the question. And I know that I only have first and fourth quadrants to choose from. I get all of that from the definition of inverse sine. Okay, so as we said, because this is negative, I have to be in the fourth quadrant. So I'm going to look in the fourth quadrant and I'm going to see where my sine value is -1/2. And of course, that is at 11 pi over 6. But if you look at the domain, -pi/2 to +pi/2, is 11 pi over 6 in that domain? No. So another name for 11 pi over 6, if I'm starting here and I'm going down pi over 6, that would be a -pi over 6, right? Those are coterminals. If you add 2 pi to -pi over 6, you get 11 pi over 6. If you subtract 2 pi from 11 pi over 6, you get -pi over 6. So it's two different names for the same point. However, if we write 11 pi over 6, it would not be within the restricted domain. So we want to write -pi over 6 instead. All right, let's look at the next one. So for the next one, we have arcsine of 1/2. So again, as soon as I see that, I know that that means that sine theta is equal to 1/2. They're giving me the answer. I'm looking for the question. We're playing Jeopardy. And I only have first and fourth quadrants to choose from. I get all of that from the definition of arcsine. So since this is positive, am I going to be in the first or in the fourth? Well, remember I'm positive in the first and negative in the fourth, so I'm going to be in the first quadrant. So I can come over here and look in the first quadrant and see where is sine equal to positive 1/2, and that is going to be at pi over 6. All right, let's look at inverse cosine. All right, inverse cosine, exact same idea. If I did the vertical line test, the cosine curve would pass that. If I did the horizontal line test, it would not pass. So I'm going to have to restrict inverse cosine to a region, and that region is from 0 to pi. Okay, well, why didn't they just use the same region that they did for inverse sine? Why didn't they use from negative pi over 2 to positive pi over 2? Well, if you'll notice, that still would not pass a horizontal line test, right? So that's why we have to select a different region. We're going to use the region from 0 to pi. All right, so if we're thinking about 0 to pi on the unit circle, 0 to pi is the first and the second quadrant, right? 0 to pi, first and second quadrant. All right, and remember that cosine is positive in the first and negative in the second. So if they ask me to do the inverse cosine of a positive value, I automatically know I'm in the first quadrant. If they ask for a negative value, I know I'm in the second quadrant. So again, when we see arc cosine of square root of 3 over 2, we know that that means that the cosine is equal to square root of 3 over 2. We're playing Jeopardy, and we only have first and second to choose from. Since it was positive, we already associated that it would be first quadrant. So let's look over here in the first quadrant. Where is cosine square root of 3 over 2? And that's going to be at pi over 6. All right, look at one more of those. So inverse cosine of negative square root of 2 over 2. All right, that means that cosine is equal to negative square root of 2 over 2, and I only have first and second quadrants to choose from. Again, I get all of that from the definition of inverse cosine. Since this is negative, what quadrant am I going to be in? I'm going to be in the second, right? Because positive in the first, negative in the second. So let's look in the second quadrant, and let's see where cosine is equal to a negative square root of 2 over 2. And there it is, right there, at 3 pi over 4. So our answer would be 3 pi over 4. All right, what about tangent? Well, we can have the same discussion about it. It's going to pass the vertical line test. It's not going to pass the horizontal line test. So we'll use a restricted region from negative pi over 2 to positive pi over 2. You'll notice that's the same region that we used for sine. The only difference is for tangent, we don't have equal to. For sine, we were able to be equal to negative pi over 2 and positive pi over 2. For tangent, we're not, because we have asymptotes at negative pi over 2 and positive pi over 2. So we're still using the first and the fourth quadrant, and tangent is positive in the first and negative in the fourth. So we're still using the right-hand side of the unit circle. Now, I've added my tangent values to my unit circle here. And the way that we get those, remember tangent is sine divided by cosine. So 1/2 divided by square root of 3 over 2 is square root of 3 over 3. Square root of 2 over 2 divided by square root of 2 over 2 is 1. And square root of 3 over 2 divided by 1/2 is square root of 3. We also could do these quadrantal angles, like 0 divided by 1 is 0, and 1 divided by 0 is undefined. Then the fourth quadrant, of course, is going to be the same as the reference angles. So pi over 6 and 11 pi over 6 have the same ordered pair. Pi over 4 and 7 pi over 4, pi over 3, and 5 pi over 3. So if their ordered pairs are the same, then you can see their tangent values would be the same, just that tangent's positive in the first and negative in the fourth. And so down here, negative 1 divided by 0 would also give me undefined. All right, so if we want to know the inverse tangent of 0, we're saying where is tangent equal to 0? And I only have first and fourth to choose from, only this right-hand side of the circle. So looking at that right-hand side of the circle, where is tangent equal to 0? Well, it's right here at 0. And again, I would want to call that 0, not 2 pi, because 0 is between negative pi over 2 and pi over 2. 2 pi is not. All right, here's another one. Arctan of square root of 3 over 3. That means that tangent is equal to square root of 3 over 3, and I only have first and fourth quadrants to choose from. Because it's a positive square root of 3 over 3, I should know I'm in the first quadrant, so I'm just going to look in the first quadrant, and there's my tangent value right there at pi over 6. So my answer would be pi over 6. Now, we also can evaluate inverse trig functions on our calculator. So grab your graphing calculator, if you would please. Where you find your inverse trig functions is right above the actual trig function. So like right above sine, you can see inverse sine, sine to the negative 1. And right above cosine, here's inverse cosine, cosine to the negative 1. And then here's inverse tangent. All right, so to do the first one, arctan of negative 8.45, I'm going to do second tangent of negative 8.45. Make sure that you do your negative sign and not your subtraction sign, or you will get a syntax error. All right, also make sure that you are in radian mode. So if you hit your mode button, you can see right here radian and degree. So go over to radian and hit enter, because you'll get a different answer if you're in degree. All right, so inverse tangent of negative 8.45. All right, the next one we had was arc sine. So let's do inverse sine. So second sine of 0.2447. All right, and then the last one we had was the arc cosine of 2. So we'll do inverse cosine of 2. And when I do, this is going to give me an error message. And the reason for that, if you'll notice, it says error domain. The problem here is that I'm asking it, tell me where cosine is equal to 2, and there is nowhere that cosine equals 2. Think about the cosine curve. It goes up to positive 1 and down to negative 1, right? There's nowhere that it's equal to 2. And so that's why my calculator is giving me the error message. All right, so again, these are the values that we just got from our calculator. And again, that idea of inverse cosine can't be 2 because the cosine curve goes up to 1 and goes down to negative 1.